Today's lecture, we are going to discuss about plate tectonics. I'm sure that you must have heard the term plate tectonics somewhere. Mostly when we talk about earthquake, when we talk about volcanoes, when we talk about mountain building, we heard this term plate tectonics. But what is this concept and how this concept is important for a civil engineer and what way it can help us? What the concept of plate tectonics, how it explains some of the features which what we see on the surface of the earth. So that is what we are going to discuss today in the lecture. So plate tectonics is a theory which is proposed or which is evolved somewhere in 1960. And this theory was combined with two earlier existing theories. One is called Continental Drift and another one is called Seafloor Spreading. So continental drift is the theory which says about the continent, the land of the surface of our earth is moving on a plastic layer. So that process we call it as the continental drift. And the seafloor spreading is the areas where new continents are forming, new land is forming. When two things which split apart, the magma, which is the molten rock, which is below the surface of the earth, which come up and which cool down and new rocks forming. So this theory is combined together, which forms a plate tectonics theory. So a theory says the Earth's outer brittle layer extending down to a depth of around 150 to 200 kilometer, and that is called lithosphere. If you remember when we discussed about the internal structure of earth, we used this term lithosphere. That lithosphere includes the crust and some part of the upper mantle. So that divides into several slabs are now in process of gradual drifting or gradual moving with reference to each other. So that process or movement of this continental part, we call it as a plate tectonics theory. So the tectonic is the study of the origin and arrangement of broad structural features of Earth's surface. So this tectonic theory, which explains that around 225 million years before our Earth was, the Earth we were having a one single landform or one single land and one single water. So as a period of time that evolved to the present situation where we are having different continents separated by ocean or sea. So this is how the process which explain the plate tectonics theory. So we'll go to the details of this plate tectonics theory. The plate tectonics theory was first proposed by in early 1900s by Alfred Wegener. So what was his observation when he was looking into the different continents and the different rock types which existing on the different continents. So he observed that the continents are having similarity in some of the rock types. For example, if you see the Africa, so some animal fossils what you are getting in the Africa, the same kind of animals we are getting from South America also. Similarly, when we see the part of India, and similarly all these different continents when he studied, so he identified there is some similarity in the distribution of animals and the rock types. Okay, so the rock types what you are getting in some part of Africa, we are having the same kind of rock types which formed in the South America also. So today in present situation, if you see this, both the continents are separated with a large quantity of water or a sea or an ocean. So this processes he helped him to understand, or he proposed that he went to revolve in a theory. So that theory is the plate tectonic theory. So now when we are talking about the plate tectonics theory, what this theory says, around 225 million years ago, there were one single land. Okay, so that single land we call it as a Pangaea. Okay, So that Pangaea is a single land which was existing around 225 million years ago, has divided into two other land masses by the force, and these two land masses are called Laurasia and Gondwana. So the sea which was covering this land in that period, now it has entered into this and it forms a sea of water which enter into this between to these landforms and it forms a sea. Similarly, the process continues around 65 million years ago. This is how the continents now it further shifted, like the Laurasia which drifted into North America, Europe and Asia, and the Gondwana land which shifted into South America, Africa, India and Australia and Antarctica. So similarly, this process continues for millions of years, and today when we see, this is the situation where our different continents are separated by different water bodies or oceans. Okay, so there are this, he was looking for the evidences of this. So some of the evidences what he could get, for example, if you see the boundary of these two continents, okay, so these two continents, if you see the boundary of these two continents, these boundaries are almost, it is like a puzzle. If you match it together or if you move it together, these boundaries matches, it fits exactly. So six are that arrangement of these boundaries of continents. Some of the boundaries he could observe, and he proposes that okay, this is matching exactly, or then it may be a process by which these continents were together once upon a time and they shifted apart. Second thing, what he has he identified the distribution of this icelands, glaciated surfaces on the earth surface. So if he put it together, it seems like once upon a time these all were together and then it drift apart, and in the present scenario these are distributed. These are the present scenario where it is distributing the glaciated glacier evidences. So this late Paleozoic is a time frame. During that time frame, the glaciation, he is able to identify that there is some similarity of that glaciations, and that indicates once upon a time these glacier phases must have been arranged in one single location, and after a period of time it shifted apart. And one more evidences that he provided is called a polar wandering curves. Polar wandering curves is nothing but it measures the polarity of magnetic polarity of these continents. When these continents are forming, when the rock types are forming, all these rock types or the sediments which are present in this continent will have a tendency to align parallel to the polarity of the earth. But if there is no change in movement of this continent, so the polarity will remain as it is. But when he studied the successive layers of sediments which has formed, he observed that there are some changes in the polarity, and he plotted that what was the direction of that polarity, and that plots we call it as the polar wandering curve. So from that polarities, when he plotted, he identified these poles are varying. So these are the evidences, we call it as the paleomagnetic evidences, magnetic polarity of the earth which is preserved in the rock type. So that polarities also indicates that okay, there are some changes in the polarity, and he proposed that must be due to the movement of continent. Okay, so these are some of the few examples. So now, as I said, okay, these are the continent initially, then it started shifting and it formed two different continents. Now the problem is that it needs a huge amount of energy to do this process. Okay, so I'm talking about a one continent, all our landforms we keep together, and we are talking about the entire African continent is shifting or moving. So the huge amount of energy which required for the movement of this continent was a question, and there are some ideas which proposes the movement or the driving force for this energy, and that driving force we call it as a mantle convection. So mantle convection is nothing but you must have seen that if you take a beaker and fill the beaker with water and heat that beaker. Okay, if the transparent heater, if you transparent beaker, if you take, what you will observe in this is that you will see that some bubbles or the movement of the water which move towards the surface, and that will come down. So this kind of rotational movements will be able to see in this water. And what happens in this, when the heating, which heated up the water in the bottom, it will have a tendency to go up, and when it reaches the surface, it cool down little bit, and that cooling process, it will bring the water down. So that kind of convection processes are happening in a beaker or water when we heat. So the process which is almost similar, but it is explained in the case of a earth mantle. So the picture what you are seeing here, this is an earth mantle and this is the core. You remember that earth is having three different layers: core, mantle and crust. So this is what we are talking about, the crust, where the hot molten magma which will have a tendency to move up because of the heating up. When it reaches towards the crust, it will cool down, and this cool down material will come to the bottom. So this creates a kind of convection current. It creates a kind of rotational movement of this magma in this part. So this rotational movements will be exerting some forces on the bottom portion of the crust which is overlying this mantle. So this forces which creates a lateral movement, and that, as a result, the continent will start moving apart. So like what it is shown here, there is an ocean crust which is moving towards one direction, and this moves another direction. As a result, the magma from the bottom or the mantle or the upper mantle which comes up and which settle down here, and it produces new rocks. When this moves in one direction, obviously what happens, the continental crust in this part which is creating obstacle to the movement of this continent. So what happens, this continent, the oceanic crust will move down and this continental crust will override. Okay, so this kind of processes will happen, and when it moves down, this goes down, and when it reaches into the mantle, it melts. As a melting, the process of melting of this oceanic crust, that will create magma again, and this magma will have a tendency to come up, and this is the places where through which the magma will come up. We call it as the volcanoes. We call it as the andesitic is a type of rock. We call it as a volcanoes. Okay, where these two things which intersect, where there is a continental crust and an oceanic crust which collide each other. So one portion of the crust, that is basically the oceanic crust, moves down and the continental crust override. So where it forms a large depression because of the friction created by these things, one part will be slightly pushed down. So that depressions which will produce, we call it as a trench. Mariana Trench, you must have heard about, is produced by the tectonic activity. And where in the part where these things shift apart, or where the magma which will come up and it will produce the new hilly terrain. This we call it as a mid-oceanic ridge. Mid-oceanic ridge is a landform which produces, and mid-oceanic ridge is a long feature which is in the boundary of two plates, and when these things move apart, which produces a valley, so that we call it as a rift valley. We'll see in the next picture what is that rift valley. So similarly, the volcanoes also forms here. So these all processes of moving down, it is not a very easy, simple process, because we are talking about a large body of continent which is moving apart, or which moving towards together. So there are some areas where the rocks will be locked down. It will not allow the other part to move. So that locking down will sometimes create friction, and sometimes it will create that lockdowns will break, and that movements will be of some kind of sudden release or breaking of the rocks. So that sudden release or breaking of the rocks, we call it as a earthquake. Okay, so this is earthquake. So these are the zones where the large amount of earthquake can be observed. Okay, so this all different landforms which are existing on the surface of the earth is all as supporting evidences of this theory of what we call it as the mantle convection. Okay, so the mantle convection is the process which that we believe creating that sufficient amount of energy providing for the movement of plates. What is the plate? Plate is the upper layer on the surface of the earth which includes the crust and some part of the mantle, and we call it is a lithosphere. So this 150 to 200 kilometer thick lithosphere, 150 to 200 kilometer thick layer of earth crust and upper mantle is moving by the process of this large amount of magmatic convection, and there are some evidences which explains the process of movement of these plates by this magmatic convection, and there are some evidences of features which explains the process of magmatic convection. Now, this plate tectonics, when we're talking about all these things, there are different, each and every, this is all our earth. If you cut and make it flat, and this is how our earth looks like. And these plate boundaries are not actually following the nation or state boundaries. These are the natural geological boundaries where there is a movement. Okay, so these are the basic major plates what we are discussing about. First one is the largest one we talk about, that is the Pacific plate. Then we have the North American plate, Pacific plate. Then we have the South American plate. Then we have the African plate. Then we have the Antarctic plate. Then we have Indian Australian plate. So you can see that this is our India here, and the Himalayas which are forming here, and this is because of what? The Indo-Australian plate which is moving towards which direction? Towards the northern direction, and where we are having an erosion plate, that erosion plate is blocking the movement of this Indo-Australian plate. As a result, this material which is climbing over this Eurasian plate, and our Himalaya is forming here. Okay, so largest system of mountain ranges which is produced by the collision of two plates, Indo-Australian plate and the Eurasian plate, and this is our Himalaya forms. And there is a small plate which is Arabian plates. Then we have Nazca plate. Then we have a Caribbean plate. So these are the minor plates. So the major plates and minor plates. So this is Philippine plate. So this plate means this is the surface of the earth, and there is a thickness where is that we call it as the lithosphere, and this lithosphere is broken into small parts, and one plate will have number of different boundaries. One is the top portion where the plate will be in plate boundary. The top boundary is the atmosphere and the surface of the earth, and the bottom boundary where we are having the astronosphere or the mantle. And here this is two plates which moves again side by side. So this is another plate, and this is one plate, and second one is another plate. So two plates between. So there are three main boundaries on the plate: the top, bottom, and the side. The sides of the plates would be either moving towards each other, or moving away from each other, or moving side by side each other. So these movements which are happening on all these plates are somewhat indicated here. So if these indications, if you understand, okay, these are actually indicating the movement of the plates. Like here this is sliding each other, here also which is moving each other. So that kind of indications, and that also indicates which plates moves down and which place moves up. Okay, so this kind of details are available, that you have had a good information available about the movement of these plates. Now, when you talk about the movement of the plates, there are basically three major type of movements. Okay, the first movement we call it as the divergent movement. Divergent movement is something this. the plates which move away from each other by the force. What force? Convection current. And the second one, it is the movement of the plates which is towards each other by the movement of force, movement of the convection current, and as a result we will produce some colliding processes here. Some landforms will be moving here, either one will go down, another will go up, or both will go up. Some kind of process will happen here in this process. And the third process is called transform fault boundaries. So transform fault boundaries, the plates are moving side by side. So there is a side by side movement of the plates. So first one, it is called a divergent boundary. So this is what we have already discussed. Because of the forces which is acting on the mantle, these plates will move apart slowly. There would be some depression, so the rifting will happen. So that will create a rift valley, and later on this rift valley will go further and further, and water may come into this. So that will create a sea, narrow sea. So the Red Sea is best example of this kind of sea created by the rift valley. So this further continues, and it can be produced large. So here this is the area where new rock is forming. Okay, so this area where new rock is forming, we call it as a mid-oceanic ridges. Okay, so Rift Valley and mid-oceanic ridges. So these are the two main landforms which is associated with the divergent movement of the plates. Next is the convergent ocean movement. Convergent ocean movement, where two plates are coming towards each other. So this movement of coming towards each other, which can happen either by a ocean convergence, or a ocean and continent convergence, or a continent convergence. Ocean convergence, ocean continent, and a continent convergence. So there are three basic ways where the convergence can happen. And in case if this convergence happens, for example, this is the ocean convergence. So both the plates are oceanic in nature. They are both in the ocean. So either of this will go down and one will go up. So in the one which is having high density, usually will go down because of the density of that. And when it goes deep into that, when it reaches the mantle, it melts down and it produces the volcanic effect. And these volcanoes, what we see on the surface or in the under the sea, that usually have follow the border or the boundary of the plate. So this kind of series of volcanoes, small volcanoes which are forming inside the sea, we call it as a volcanic island arc. Okay, so these volcanoes sometimes grow above the surface, water surface, and we will see some small islands on the surface. Okay, so that is the volcanic islands, and here it forms a trench. Okay, where two things collide each other, which will collide and forms a trench. And these zones are highly earthquake producing in nature. If you go for an ocean and continental convergence, in this case, what happens? The oceanic crust will go down because of the high density of the oceanic crust. As if you remember, I discussed about the crust. We are having two type of crust: continental crust and the oceanic crust. And the continental crust is produced of silicon and aluminium, whereas the oceanic crusts are made up of silicon and magnesium. Cl and Sima we discussed. Okay, silicon and magnesiums are highly dense, so that will have a high density in the oceanic crust comparing to the continental crust. As a result, when both the things comes together, the oceanic crust will go down and the continental crust will override. Okay, so here also there are formation of trench where there is a collision. So in front of that there would be the continental crust, and then there are different terminologies we use for arc bracing, and this will create a mountain belt, and below that and towards the land we get a backyard basin, and in front of that we get a sedimentary basin. Okay, so this kind of things happens in the case of a convergent movement of continental and oceanic. So when there is a continental and continental convergence, it produces a fault mountains. And if you see the Himalaya, the process of Himalayan formation is started around somewhere in the 71 million years before the movement of India mass, which started towards the north, and it comes down and it collided with the Eurasian plate around 10 million years ago. Before that, all this part was covered with water or sea, and when it collided to this Eurasian plate, it started creating the mountains. Okay, so that is what the fold mountains what we see in the Himalaya. And whatever the sediments or the water which was here while the movement of this Indian plate, that is now available in the top of the hill. That is why in today also, if you go to the top of the Himalaya, we will get some fossils. Fossils means the remains of old existing organisms. We get the fossils of marine organisms from the top of the Himalaya. So this is again the process of continental collision, and the last one is the transform fault boundary. So this is comparatively a stable, which generally may not create much larger troubles. So the two plates, which will be, this will be passive, call it as a passive boundary. There is no much dynamic effect like earthquakes and all, and there is no major landforms which produces in the case of a transform fault boundaries.